take a look at another example here. I want to find all a relative or local absolute extrema on the interval -1 to 3 for this function. Then I'm going to verify my work with a graph. So first thing I need to do is find the first derivative. So f prime of x equals 2 minus 2x to the -1/3, which is 2 minus 2 over the cube root of x. Now for critical values, I can see just by inspection that this equals 0 when x equals 1. And I also know that it's undefined for x equals 0. So I have 0 and 1 as my two critical values. There are no other values of x that would make this 0, no other values that would make this undefined. So I need to go ahead and take a look at my original function f at these endpoints and at these critical values. So f of -1 equals a -5. F of 3 equals is approximately a -0.2405. F of 1, now I'm looking at the critical values, equals a -1. And f of 0 is equal to 0. So what do I have? I have -5 is the smallest value, so this is the absolute minimum. 0 is the biggest value, so this is the absolute max. Now I also need to, once again, consider these critical values and see if those are mins or maxes, or local mins and maxes. So I'm going to set it up just like I have before. I'm going to make this little chart. There's 1 and 0 as my two critical values. And I'm looking at f prime of x. And I need a value of x between 0 and -1. So how about like -0.5? When I put a -0.5 in there, or in the second derivative, what I end up with is a positive number. I don't care what the actual value is. All I care whether it's positive or negative. Between 0 and 1, how about a half? And when I do that, I get a negative. Bigger than 1, but I'm going to stay within this interval, 3, so I'm going to pick a 2. And when I do that, I get a positive. So now I know that I have a local max at x equals 0, a local min at x equals 1, and of course I already said that my absolute mins and max is at, see, the absolute max was at 0, which is also the same as the local max, and the absolute min was at x equals -1. So let's go ahead and jump into Maple and very quickly produce a graph of this and verify what we just solved. So back here in Maple, I'm going to say, see, f of x equals 2x minus 3. Now, be careful with this. Maple has a really tough time with exponential or radicals represented as fractional exponents. So I'm going to come over here to common symbols to make sure, oop, that's not what I wanted. Sorry, I wanted expressions. And right here, I'm going to take the nth root of a. So click on that, and n is going to be 3, because it's a cube root. And then a is actually going to be x, but I'm going to go ahead and square it. So that is x to the 3/2. So that's 3 times x to the 3/2. And you can see the way that Maple changes it. Okay, so now I'm just going to plot f of x. X equals -1 to 3, because those are my my bounds on my closed interval. And there we go. Now notice that the point where the first derivative was undefined, right there, I actually have a cusp. This is not a smooth curve. The first derivative is undefined here, but it is a local max. Matter of fact, it is an absolute max. And then over here, right in here someplace, actually we know exactly where it is. It's x equals 1. That's where my local minimum is. So the work that we did agrees with the graph.